up until this point, don't you love it when I say that? I would start up until this point, we've done this. It's not a math. Oh, no. It could be, I guess, but it's not. It just means basically we've learned something and then we add something else.
Like if we're told up until this point, addition is only 2b.
Yeah. Sure. All right. So we've been solving things like this. Sine x is equal to a half, or even sine x squared plus, I don't know, sine x is equal to 1 or whatever, like the one we just did. Now we're going to start solving things like this. Look at the variable x. What's the coefficient in front of it?
3.
Oh, yeah, okay. The one I circled, yes, 3. But up until now, it's always been 1. Okay, so what value is that? A, B, C, D, or A, B, H, K?
Oh, right.
It's a B value, right? What does the B value do to the graph? It stretches it horizontally. So it does this. So if you look at this, if we say, okay, we're going to look at it visually first. Cos x is equal to negative root 3 over 2. What that means is cosine graph, we know, starts at 1. And it looks like this. Right? That's cosine graph. Cos x. And then where does it equal negative root 3 over 2? Well, negative root 3 over 2, I'm just going to guesstimate where that is. Say it's there. There are your answers, right? Where those two lines intersect. That's what we're doing when we solve these questions. We're finding where those lines intersect. And in this case, I'll just give you the answers. We don't actually have to do it. 150 and 210. Okay, everybody okay with that? That's what we've been doing so far. But now, if I look at this one here, I have a b value of 2. What does that do to the graph? How does it stretch it? By a factor of a half, right? So it's a compression. So this is a horizontal compression by a half. It shrinks the graph. So the cosine graph will now go from, oh, sorry, that's not negative 1. Starts at 1 still, but because we shrink it in half, everything gets cut. All right, the period gets shrunk or decreases. That's a better way to say it. The period decreases by a factor of a half. So the period's 180. But our domain is still 360 for the question. So we know that the graph would then just repeat again, right? Correct?
Wouldn't it still reach the negative 1?
Yeah, I'm just realizing that I'm just going to move the negative 1 up. There's negative 1. So it still goes down all the way. We just shrunk it horizontally. Now, the root 3 over 2 still stays in the same spot. So how many answers do we get now? You get 4 answers. You've increased the number of answers over the same domain. And if you look at the answers, what has happened to the answers? So if we went from 150 to 75. It got cut in half, just like the graph that got shrunk. Okay? And 210 to 105 got cut in half. How do you go from 75 to 255, or probably easier to see, 105 to 285? What am I adding to get there? 180. What's the period of a cosine graph with a b value of 2? 180, right? Because if you remember the formula, or you can just see it, but the period is 360 over your b value. Your b value is 2, so it's 180. So we're going to, when we start solving these algebraically, we're going to solve them the way we did over here, like this, as if it's just an x value, and I'll show you how to do that. And then we're going to be dividing by whatever our b value is to get these, okay? And then to get the rest of the answers, you just add multiples of the period, okay? So it's very similar to what we've been doing. We're just adding this new little step. What if I wrote this? Cos 3x is equal to negative root 3 over 2. How many solutions over the same domain? Domain is, you're going to have 6, right? I don't know who said that. Right? Because you're going to shrink it by a factor of 3. What if I wrote cos 5x is equal to negative root 3 over 2? How many solutions? You'd have 10 solutions. Okay, because you have 2 over the regular domain. So essentially, now this doesn't work for everything. You will start to see how it works the more we do. But you multiply this b value by 2, and that will give you your number of solutions between 0 and 360. Now I can change the domain, and then that's going to change things. But it basically doubles the number of solutions. Okay? All right. One more thing. If I ask for the, you know what, we'll just do that when we do it algebraically. Are there any questions? This is the visual representation of what we're about to do algebraically. No, because I'm going to show you, you're going to solve it initially like we did here. So you'll get the 2, and then we're going to figure out the rest of the solutions, which is what algebraically you have to do some math, but it's just addition and subtraction and stuff. So, okay? But no, you only get 2 factors. Do you have a question? All right. Let's skip to page 621, please. Okay. Sine 2x is equal to negative 1/2. So you can do a substitution if you want to make it a little better here, just because we have this a little more consistent with what we've been doing. So I can just go, I don't know, what variable do you want to use? A. Question. We'll just say a is equal to 2x, okay? So this really becomes sine of a is equal to negative 1/2, okay? That is exactly the same as what we did in Trig 1, all right? To solve this, the way it's written right now, what quadrants is sine negative?
3 and 4.
3 and 4. What is my reference angle?
Um, 30 degrees.
30 degrees. Yeah, you can do special triangle or you can do your calculator. It doesn't matter. Okay, so what does A equal?
210.
Yeah, I'm talking about the angles here. Yeah, 210 and 330, right? Now, we're not actually solving for a. We're solving for x. And we made a substitution saying a is 2x. So I have to put that back into here. So I actually go 2x is equal to 210, 330. Does everybody understand that bit?
Yeah.
Okay, I don't want to solve for 2x. I want to solve for x. So what do? Divide by 2. You divide everything by 2. So you're dividing both these angles by 2. So you get x is equal to, thank you, 105, and thank you, 165. There we go. Okay. Those are not all the answers, though. Because how many answers should we have? You should have 4, right? Because we have a 2 here, and you're always settled 2 times the 2 gives you 4. So we know we should have 4. So what you do to get the rest of the answers is you add multiples of the period. So what is the period of the original graph? Or of the original function? Sine 2x. Not 360. It's 180 because period is 360 over your b value, and your b value here is 2. So it's 360 over 2 is equal to 180. Does that make sense? So we know the period's 180 degrees. So I add 180 to 105. What does that give me? 285. Then you add 180 to 165. 345. And you keep going until you exceed your domain. Because our domain is 0 to 2 pi or 0 to 360. We'll convert to rads at the end. So if I added 180 to the next one, to 285, sorry, what does that give me? 525, thank you. But that exceeds the domain, so you stop, you exclude it, and you know those first 4 are your answers. Okay? Outside domain. Okay, so I don't want these in degrees, I want them in rads. Okay, so what do we do to get them into rads? Multiply by what? Multiply by pi over 180. So times by pi over 180. You can just give me the decimals, which are 1.83, 2.88, 4.97, and 6.02. No? You can do the exact value if you want, but I'm not going to ask for the exact value. Exact value, I would use that and then convert them, but I don't really care right now. Does that make sense? The only new thing is that 2 as a b, the b value basically, and all you do is you solve it normally, and then you divide off your b value to get your new answers, and then add multiples of the period. But you don't add just blindly 360. You have to look at the period based on the b value there. No.
We're gonna get to the point, aren't we, where there's also an a value, a c value.
No.
No, we're not.
Because the a value, when you do that, like that's.
Like, isn't that technically what we've already?
We've already done it because if you have this,
We just added.
you divide it off, right? And then you're just essentially solving sine x
Will we
equals
have to
to half.
Will we have to work with the h or k value?
No, because those the h value, that's no.
It's once again, it's just.
It's going to be inside, and that's a more complicated because you get like this.
Yeah. That's,
I mean, it's not really. I mean, you solve it normally and you add the 4 over.
but it's just extra work for them.
Yeah, and if you have the k value, right? Well, that's just
Which we've already been doing.
you move it over, and yeah, so we've already done. The b is the only one that really changes how it looks. The other ones we kind of just naturally just do it because it's addition and subtraction.
Are we gonna get questions with a b value be like some of one was not 2 and it won't divide by what like the degrees? So if it's like 210 but it's not is that gonna happen?
Yeah.
Okay, and we can just
But then you just deal with decimals, right? Okay. General solution to this equation. What did we do for general solution yesterday? We took all the answers from the first bit, which we do the exact same thing. So you go 1.83, 2.88, 4.97, 6.02, and what do you add? Multiples of the period. But what's the period of this graph? 180. So you go n pi. So just be careful about that. Okay? So you can literally take all those, or you can realize you really just have to take the first two, right? Because if I add 180 to that, I get that one. But if you want to be safe, just take them all and add multiples of the period. Yes?
If this was, if you were using 10 in this case, would it be?
It'd be, the period is pi or 180 over b for a tan graph.
So then if we had to divide by 2 like this, then
It'd be 90.
So it would be plus n pi over 2 or something?
Yeah.
Okay.
So pretty much the general solution formula is n 2 pi over b
For sine and cosine.
for sine and cosine.
For tan, it would be n
For
pi
tan, it
over
would be
b.
180. Or
Yeah.
1 pi, but
Yeah. Yeah,
in this case.
exactly. All right, is that okay? It's only got one sort of new thing in it. All right, here's the questions I want you to do. Number 4, number 5, and 6, please. 4, 5, 6, please. Okay, so we have the equation of the Ferris wheel. -4 cos pi over 12t plus 5, where h is the height above the ground, t is time in seconds. Okay. Determine the time it takes for the Ferris wheel to go around once. If I ask you to tell me the time it takes to go around once, what am I really asking for? The period, right? I'm asking for the period because it's one complete rotation. So this is basically the period. What is the formula for a period of a cosine graph? 360 over b, except when we're dealing with these types of real world problems, time is not measured in degrees, right? So we have to use rads. Can we ask it after? Thank you. All right. Period is equal to 2 pi over b. It has to be in rads, okay? So our b value, what's our b value? Pi over 12. So everybody knows how to divide fractions. So what's the period? 24 seconds to go all around once. That's a fairly fast Ferris wheel, isn't it?
I'll be terrified.
24 seconds to go make, I mean, depending on how big it is. Just a tiny little one. But if it's a big one, that's like, it's moving pretty quick.
That little car table you're sitting in, we'd be like getting air, be flipping up as you go over the top.
That'd be kind of fun, wouldn't it? You'd probably be weightless coming down.
You would probably be far.
Yeah.
In fact, no, it would probably be
You'd hit the ceiling.
You get like the
Go
G-force. Like,
boom, be like in an elevator. Okay, this is all being recorded, so maybe we'll stop. All right, so algebraically determine the times during the first minute of the ride when the student is 7 meters above the ground. So this is the bonus question from Trig 1 test. And some people got that question. So basically I'm saying, when are you 7 meters above the ground? So I'm saying when the height is 7, right? When this is 7. So really you're solving this question. So this goes to your question, Noah. Are we going to have to deal with all the other letters? And you do, but really, it's just algebra, right? You just manipulate it to get it to look like something we know how to solve. So we're going to solve for t. Now, that's a bit of a gong show the way it's written, so we have to rewrite it. So what am I going to do? Subtract 5, so 7 minus 5 is 2. I'm going to divide off the negative 4. Now that is something we know how to solve. Negative 1/2 cos pi over 12t. Because that's, I mean, I could write 2t or 2x or whatever, right? The pi over 12 is the b value. So we're going to solve it. Do we want to do a substitution method, or can we just do it? All right, so you pretend that you're solving just cos is equal to negative 1/2. Where is cosine negative? 2 and 3. What is my reference angle? Or you can use the triangles up there. 60 degrees. So that means pi over 12t is equal to what? 120 and 240. Does that make any sense? In terms of units, I guess I should say. It's not in rads. It doesn't make any sense the way it's written right now, right? Because time is not measured in degrees. So we're going to convert 120 and 240 to rads. 120 is 2 pi over 3. And that's 4 pi over 3, right? Pi over 12t. That's actually what I'm going to suggest you do. Because 2 pi over 3 seconds, I don't know what the heck that is, right? So let's convert it to decimals. It makes a little more sense. What is 2 pi over 3?
2.09 seconds.
So we're going to rewrite it like this. .09. Let's go to 2 decimals. And then multiply that by 2. 4.18. Okay. So what do I do now? And divide by 3, right? Or pi, sorry. Multiply by 12 and divide by pi. Correct? So for each one, I'm going to get t is equal to, is that what it is? 7.98? Do they want us to round to something here? Nope, it doesn't. Okay, 7.98. And what was the other one?
15.97.
Let's round to whole numbers here just to make our lives easier. So 8 and 16. 8 and 16 seconds. Okay. What is that? Am I done? You know when I say that, it's the answer is no. But the question is, why am I not done? What does the question say? Yeah, during the first minute of the ride. And these are in seconds, correct? So how many seconds are in a minute? 60. So how do I get the rest of the times? You add the period, right? What's the period of the graph? 24 seconds, right? That's what we did right at the beginning. It takes 24 seconds to go around. So during the first what am I trying to say here? Thank you. The first rotation at 8 seconds and 16 seconds, we're at a height of 7. Then it does the second one. So I add 24 and 24. So then I get 32 and 40. And you just keep going until you go past 60 seconds. So the next one, if I add 24 to 32, I get 56. But then if you do one more, you're outside. So these are your answers. 60? What did Kyle say? How many? Okay. That may have been recorded, Kyle. So you just keep adding until you exceed 1 minute, which is 60 seconds. Okay? So at 8 seconds, 16 seconds, 32 seconds, 40 seconds, 56 seconds, you are at a height of 7 meters. Why you would need to know that, I don't know, but if you wanted to predict on that very fast Ferris wheel that you're on. Number 8, please.